Okay, so we will be discussing about the tRNA today. So as you got all know that what is tRNA, that is transfer or translation of the RNA. This is proposed by holy scientist. Okay, in 1965, 70 to 90 nucleotides are present in tRNA, and tRNA in cytoplasm, that is 10 to 20%. It is single stranded, but at some region it become double because of some bases. If you're talking about the AMU, the molecular weight, that is 25,000. Okay, 25,000. Okay, AMU. If you're talking about, so they are having it has anticodon. What is anticodon? That decode the codon. But as you can see that from mRNA information is coming, that is the codon, that is the genetic code, or you can see that the information is moving to the and in the form of the genetic code from anticodon to anticodon, or they decode the code that is having a anticodon too. If you're talking about the upper arm is the acceptor. Okay, acceptor arm that receives the mRNA information. Okay, we will be discussing about this model too. If you're talking about the cytosol, how much this is present in cytosol, as you can see that the cytosol is the soluble part of the cytoplasm, and we take amino acid from here. Okay, so here you can see that in cytosol 96% of protein is there and 4% of the carbohydrate is there. Okay, if you're talking about the there are 44 tRNA in human, and you can say that the generally we are having a 60 tRNA. Okay, so it is the we'll be also discussing about the structure of tRNA too. So it is having three-dimensional axis, which means that it is in x-axis, y-axis, and in the z-axis too. Okay, so they are having total 5 arms, okay, and 4 loops. How? Let's talk about that. So this is the structure of the tRNA. Okay, so this is the they are in axis, as you can see that is an x-axis, this is in y-axis, this is in z-axis too. So they are 3 dimensions, and they are having 5 arms, 1 2 3 4 5. If you're talking about loops, they are having 4 loop. What is loop? Loop means there is an arm, and that structure is a loop, and this is the accepted arm. This is having no loop, but these all are having the loops. Okay, we are saying that as the loop T, and this is anticodon, and this is the acceptor arm, and you can loop T is this, and if I'm talking about this, so this is the variable loop. Okay, so let's talk about acceptor first. So acceptor is having the 7 pair nitrogenous bases, but single bases they are having 4. Okay, and acceptor receive the information from the mRNA. If you're talking about the D loop, so D loop is having what is the full form of the D loop? That is a dihydrouridine. Okay, means they are having 2 hydrogen. Uridine, that means that uracil plus pentose sugar or 5 carbon sugar. Okay, In loop of the D, they are having the 8 to 12 nucleotide, and in arm they are having the 3 to 4 bases, but in pair form. If you're talking about the, you can say that if you're talking about the anticodon, this one, so anticodon is made up of 5 bases pair. Okay, they are made up of 5 bases pair, and they are having a loop, that the loop is having the 7 nucleotide, but from them the 3 nucleotide work as the anticodon. Okay, so this was about the anticodon. If you're talking about the variable arm, or you can say that the small arm, that is this one. Okay, so this is the variable arm, and this is third loop, and they are having more nucleotides than others loop, means they are having 4 to 21 nucleotide. If you're, as you can all know that if the variable arm is having more nucleotides, so their length will increase, and if they are having less nucleotides, so their length will decrease. That's why it is called variable. Okay, so if you're talking about the last arm, that is T arm, or T, you can say that T arm. We can also, they are also called T and C arm, and this is denoted by this. Okay, this is the T arm. We're talking about this. Okay, so T arm is the fourth one, and fourth one loop, and this is on x-axis, as you guys all know. Their loop is having the 7 nucleotide, and their arm is having 5 bases, that is in pairs. If you're talking about the function, so function of all them is all the arm is having that the transport of amino to cytoplasm, okay, to the site of protein synthesis, means to make the protein. What does it mean? It means cytosol to amino acid. We are getting amino acid from cytosol, and amino acid is going to ribosome. And as you guys all know, ribosome is present in endoplasm reticular, and the ribosome is made in the nucleolus. Okay, so but as you guys all know that tRNA is coded for specific amino acid. Specific amino acid means it has 3 nitrogenous base. What does it mean? It means that, as you guys all know, one codon was having 3 nitrogenous bases, so that is the 3 nitrogenous base means one codon. Okay, and you can say that if there are 20 amino acid, as you can see, we are having 20 amino acid, so 20 amino acid are there, so they are having a, for each amino acid there is a tRNA, so 20 amino acids, so 20 tRNA types, but total they are 60, but in humans tRNA is the 45. If you're talking about the function of this, so that is the tRNA, and if you're talking about the function, that is that the acceptor arm will let's talk about the function. Acceptor arm will receive the information from the mRNA, and it will move to the anticodon downward first of all. Okay, it will get the information, decode it, and the information will store into the D and the T loop. So that is all the structure of the tRNA. So this was the structure of the tRNA and the information about all the arms and the loops.